Hi, I'm Pradeep. I'm the team leader, and I worked on analysis, IRB or Institution of Review Board approval, and subject recruitment. This is Julie. She worked on IRB approval and collection. Michael worked on collection and extraction automation. G worked on analysis and extraction, and then Alex worked on extraction and modeling. So we did a project on the impact of vocal effort on speech. So speech recognition systems are increasingly making their way into modern technology. And we see this in Cortana, Siri, Google Assistant, and a number of other applications. And one issue that these systems have is that they're trained on data that has a lack of vocal effort and are not attuned to data that deviates from that norm. Vocal effort is the way that humans change their voices to respond to different situations like communication distance and emotional fluctuation. In our project, we specifically focused on the impact of frustration on speech. And this is a very relevant application because when someone uses something like Siri and it doesn't work, they naturally become frustrated and change their voice as a result of that. And that makes Siri actually work less effectively than it did before. So it's a very relevant issue. So the first thing that we had to do was collect a corpus of frustrated and non-frustrated speech. So we can compare the trends in both of those pools. So we had to go through the UTD IRB to get approval for our experimental setup. You can see a picture of the lab in the slide up here. So we had 30 subjects come in, and basically what we did was we told them they were working with this new voice recognition system. But in reality, it was us that was like manually inputting negative feedback to the system, so they were getting frustrated because of the negative impact that we were giving them. Yeah. So the 4 feature parameters that we looked at were fundamental frequency, spectral tilt, energy, and duration. And we looked at percent differences because people have different baselines for each of these 4 parameters. So the chart on the right here shows a summary of our findings. Because of our small sample size, we opted to look at relative rankings for each of these parameters, and we put together an overall ranking metric based on those 4 individual rankings. So we separately classified each of our subjects as having or not having frustration in them based on what we heard. And of the 10 subjects that we found were frustrated, 7 of those 10 were in the top half of our ranking system, so that supports our findings. In terms of overall outcomes, we can kind of see that F naught, the leftmost column, and duration on the right, second to rightmost column, have the cleanest trends, it looks like. So we would anticipate that those 2 features are most closely related to frustration. Statistically significant conclusions are difficult to make at this point because of our small sample size, but the trends are promising, and with a larger pool of data, we can probably expand on those trends. Thank you.
Any questions? So I have one. So I kind of understand the process that you're measuring, you're trying to quantify the frustration level that one person goes through. So you're working with Cirrus Logic. How would they use this information in their product, or to make a better series or a Google Assistant or whatever? So I think the ultimate idea is essentially that if we were to start incorporating frustrated data into training data, and we found that there's substantial reason to do that and invest the time and money into having that addition to the training kind of procedure, then eventually a machine might be able to toggle between 2 modes, one being neutral data and one being frustrated interpretation. And so if, say, Alexa is determining that you've kind of changed into a frustrated mode, maybe her detection capabilities are adjusted to that parameter. And so it's essentially a proof of concept for a need to incorporate more frustrated training data into these models in order to kind of allow for more variability in voice and detection.
When you did the sampling data, was this done subjectively? You're just listening and trying to sort it into this, or was it somehow done more objectively through some kind of voice analysis? Or can you tell me kind of more how that table came to be?
So as far as the rankings here go, so number 1 is the most frustrated according to each metric. Now historically, when linguists study vocal effort in speech, they tend to associate positive percent differences with each of these 4 features with being more frustrated. And so that's the assumption that we made with this model, is that the most positive percent difference got the highest rating in terms of frustration. And so we kind of relied on, past linguistic research in order to kind of come to that conclusion. Whether or not that's an accurate model for frustration is difficult, just because, this has a psychological element, whereas previous research is more based on distance and noise contamination. And so our project is quite a bit different from what's been done before. And the overall over here, each subject was assigned a score based on their other 4 rankings, and then the lowest score was ranked number 1. And so the overall is literally just a function of the other 4 features. And so kind of the significance here is, if you see a full red band, that tends to indicate some sort of correspondence. Whereas, overall is kind of less of a metric, just because it relies on the other factors. And so it's a direct result of those.
Can you explain tilt?
Spectral tilt is the slope of band powers going from low frequency to high frequency. So lower tilt would indicate that higher frequency has lower energy, while the low frequency content has higher energy. While higher tilt would indicate increase in the energy in higher frequency bands and a decrease in lower frequency bands.
So if I get more excited, I get higher frequency, or?
That would depend on how you would change your voice. If you increased how much higher frequency content you put inside your voice, so let's say a higher pitched person, then that energy band would increase, so that would increase the tilt.
Yeah, I think Alexa can figure it out now.
One last one.
Quick question. So you obviously developed software for each of these metrics, and you assessed all the subjects you collected. If subjects were bilingual, so you assessed this all in English, do you think it would carry over if they were speaking a different language but be the same subjects?
I would anticipate so. I mean, I don't know.
Let me rephrase it. Do you think the 4 features that you have are language independent? Maybe is a good question.
I would imagine so. I don't know how exactly people in other languages would change their voices to different situations, so maybe there's some cultural influence there. But that is definitely something to look into. I would imagine that they would be pretty consistent.
Okay, let's thank the team.